Good day. For those of you who don't know me, my name is Douglas Harder, and in this topic, we're going to discuss the zero vector. So in this topic, we will define the zero vector, we will describe the representation, and describe some of its significance. So in n dimensions, the zero vector is a vector with n entries, all of which are zero. It is represented with a bold 0 with a subscript n, where n specifies the dimension. Here we see the 2-dimensional zero vector, the 5-dimensional zero vector, and the 8-dimensional zero vector. The zero vector is the same for r to the n and c to the n. It's just the vector with all 0 entries. We may refer to the zero vector alternatively as the origin, very often if we are in 2 or 3 dimensions. But the zero vector can also alternatively simply be referred to as the origin. If the dimension is obvious or not really relevant to the question at hand, we may just use a boldface 0. The zero vector is going to play a similar role to the zero element in a field when we start dealing with vector addition. If the zero vector is being handwritten, it will be a 0 with an arrow above it. So either a 0 with an arrow with a subscript n, or a subscript 3 if it's specifically the 3-dimensional zero vector, or it just may be a 0 with a vector above it. So, following this topic, you now understand the idea of the zero vector. You also know that will be represented either as a boldface 0 with a subscript n, or on the blackboard as a 0 with an arrow above it, also subscripted n. You're also aware that we may leave off the n if the dimension is either obvious or irrelevant to the question at hand. Here's the references, acknowledgements, the colophon, and a disclaimer. Cheers!